So some more questions or doubts related to the past paper is which of these molecules is the most polar? If we need the polar, we need a greater difference in electronegativity. Means, and in the periodic table, we'll check the element like the as we move across the period, the electronegativity increases. So for the most difference in the or the most polar, one of the atoms should be on the far right hand side, another one should be on the far left hand side. They will have the maximum difference in their electronegativity. So all of them fluorine are there, but this is like hydrogen is here, the first, and this is 7. When we check, this is group 6 and this is group 7. This is group 3 and this is group 7. This is group 4 and this is group 7. So the highest, like maximum spacing between the two atoms means they will have a large difference of the electronegativity. So in HF, we'll have the maximum difference of the electronegativity. Is it clear? No, they did not ask which molecule. They asked which of these molecule is the most polar. Like the idea is, yeah, they will definitely cancel out each other like CH4 and that all. But when you check the two things you have to check, when you're checking the molecules, the polarity of the molecule, you have to check the difference in the electronegativity. That is one thing, like how much there's a difference in the electronegativity. And the second thing you check is the shape of the molecule. So difference of the electronegativity should be higher and the shape of the molecule, so it should not cancel out. Like it cannot be trigonal, because if it's a trigonal and identical atoms are there, or it will be a tetrahedral identical atom, so they also cancel out each other. Like if I have BF3 is there, or I have CH4, even though the bonds are polar, but the molecule, the overall dipole moment will be 0. And CF4. So they are non-polar molecule because they overall, even though the bond can be polar, but the molecular geometry cancel out each other, like symmetrical molecules. And in HF, hydrogen fluoride is there, and in oxygen is bonded with fluorine. But the main idea is like difference in the electronegativity and the geometry of the molecule. That both decide the nature of the molecule. Is it clear? Yeah, OF2 is not symmetrical. That's right. So it will also be polar. But we need the most polar. Most polar means like greatest difference in the electronegativity. Like first we identify these two molecules will be polar and the most polar based on the greater difference in the electronegativity. Because oxygen and fluorine will have a smaller difference in the electronegativity. What is the iopic name of this alkane? So first thing we select the longest carbon chain 1, 2, 3, 4, 5, 6, 7 or 1, 2, 3, 4, 5, 6, 7 or 8 or 1, 2, 3, 4, 5 or 1, 2, 3, 4, 5, 6, 7 or 1, 2. So maximum we get 8. 1, 2, 3, 4, 5, 6, 7 and 8. So we got 8 carbon atoms maximum. 1, 2, 3, 4, 5, 6, 7 and 8 are there. And then we count the carbon atoms. So 1, like which are outside our branches. Then we count the carbon atom. Numbering should always start with the nearest branch. So if I count from here 1, 2 and third position, I have a branch. If I count from here 1, 2, 3, 4, 5, 6, 7 and 8. So second position, third position, fourth position and sixth position, I have the branches. So second position, third position, Fourth position and sixth position, I have the branches. And how many of them? Three of them. So I'll call tri. Each is having one carbon chain, so it is methyl. And then 8 carbon atoms are there, so it will be octane. So 3,4,6 trimethyl octane. So 3,4,6 trimethyl octane. So C should be the right answer. Is it clear? This one? So whenever you select the, like naming the compound, you always select the longest chain of the carbon. The mass spectrum of a sample of a sulfur 32 as only isotope. Calculate the number of sulfur atoms in molecular ion. Look, this one, they give us that this has an abundance 100%. So if I take this, why others are there, other peaks are there, there might be like sulfur is like losing different number of electrons. That's why the mass, these are the mass to charge ratio. So if the charge is greater, the mass to charge ratio peaks will be. So this is 100% is 64. And so we need the number of the sulfur atoms in the molecular ions, molecular ion. So we have like 32 is there, 64 is there, 96 is there, 126, 160, 192, 256. So these can be different combinations of the sulfur. If sulfur was the molecular ion, what is it refers to a molecular ion? Molecular ion is the highest one, highest mass to charge ratio is called a molecular ion peak. So how many sulfur are there in 256? So what we will do 256 divided by 32. What's the answer? 256 by 32. 256 divided by 32. So it means eight atoms are there. So in the molecular ion, this is due to S8. And this is representing the base peak, like most of the sulfur break down into this. Like most of the sulfur are S2 because this is 64. Or it can be like due to a removal of 2 electrons, 3 electrons. That's why the mass to charge ratio will change. Because we assume they are singly charged. Which of the ions has the greatest ionic radii? For greater ionic radii, the number of the protons should be less and the electrons should be more. In a nitrogen, we have 7 protons and we have 10 electrons. In fluorine, we have 9 protons and we have 10 electrons. In sodium, we have 11 protons and we have 10 electrons. In aluminium, we have 13 protons and we have 10 electrons. So to have a greatest ionic radii, it should have a small, like less protons and more electrons. So like the difference between the proton to electron is 3 here. This is because the electron should be more. So these two cannot be an option. So we are left with A or B, but this has a difference of 1, this has a difference of 3. So nitrogen is having a greater ionic radii. The smallest one, which has the smallest one, then aluminium will be there. Is it clear, this one? Any other doubt or a question? Any other doubt, question related to exam or the past paper? No doubt.